turn on LED.
Okay.
Alexa, turn off LED.
Okay.
Turn on LED.
Done.
Turn on the generator.
Okay.
Alexa, play Biggie Smalls, turn on generator, and turn on LED.
Okay. Okay. Shuffling songs by the Notorious B.I.G. on Amazon Music.
Turn on generator and turn on LED.
Okay. Okay.
Now to explain what's going on with this circuit, you have the 12 volt DC supply right here. So this is basically the power source for the entire battery. So you have the 12 volt DC that feeds directly into this DC motor. But before it gets to the motor, it has to pass through this potentiometer. So that potentiometer just controls the voltage, the amount of voltage that gets to this motor right here. And based on the amount of voltage that motor gets, that's going to control the amount of RPM. So now when the voltage finally gets to the DC motor, when it gets the desired voltage, and due to the fact that both of these motors are coupled, it's going to cause this one to spin as well. And while this spins, it's going to cause a current to generate out to these wires behind here. And that generated current now is going to feed into this transformer. This transformer is a step-up transformer to 12 volts DC. So now with that 12 volts now, it's going to feed directly into this panel, which is simultaneously connected to the power inverter right here. So now this power inverter now, this converts that small 12 volt DC voltage into an AC voltage. So it inverts the signal from DC to AC and steps it up to 110. So that's what this does. Devices now, you have the DC voltmeter right here. So this is directly connected to the battery. So what this does, the purpose for this is that it tells you the voltage across the battery terminals at all times. So for example, let's say you want to apply a load to the circuit through here, through the inverter. Whenever a load is applied, you would see the voltage drop across the system. So for example, alright, so whenever a load is applied to the system, it's going to decrease the voltage across the battery, because it's basically work done on the battery. So let's say I want to turn on the system. So the motor is considered as a load. So I'm going to turn it on. You should see the change in the voltmeter. This Arduino board here, this basically has one function in the circuit. This just controls what's being displayed on this LCD screen right here. So I could program whatever I want it to display. This PCB board is a solar charge controller. This controls the charge that is coming from the solar panel, and this multimeter is telling me how much charge the solar panel is getting at the moment. And it's really low because it's a small LED light. It's a small bulb. So this small green PCB board, this is basically the power supply circuit for the LED strips. This motherboard also reads the frequency that comes from these buttons on the remote. And each of these buttons have a particular frequency that corresponds to the color on the remote. So this PCB board is directly connected to this IR sensor. So this IR sensor is what reads the frequency from the remote. So this is the brains of the circuit. So this basically understands what each frequency means. So it reads the frequency and relays that signal to this LED strip. And the LED strip is connected to the board through this connector right here. So this now is a speed controller. This is basically what connected to this. So this is actually what controls the speed of the motor. So how it does that is, this is a potentiometer with a knob on top of it, and the potentiometer is basically a variable resistor. So the higher the resistance, the less voltage that's going to be passing through the circuit, and vice versa. This is what enables the circuit to be connected to the Wi-Fi. And with the circuit being connected to the Wi-Fi, it enables me to use the Alexa and the Siri to turn on and turn off the circuit. So it's a circuit with two pathways, so I could control each of these sides individually or at the same time. But yeah, that's basically the run-ins for this entire circuit.